Hi. So now let's talk about the last task or last set of tasks in AI, which is I've bundled them together as communication, perception, and actuation. So let me tell you what each of these are, and if at all they have some relation to data science, right? So communication, right? So traditionally AI agents or robots were required to communicate with humans, right? They were supposed to be in the service of humans, which requires them to communicate with them. And the default choice for communication, of course, is language, because that's what humans communicate with. So now if you want to have an agent to be able to communicate with language, you need it to have natural language understanding as well as the ability to generate language, right? It should not only understand what I'm saying, but also be able to generate its own sentences and reply back to me, right? This collectively falls under natural language processing, right? And this natural language processing has evolved over the years. And earlier, right, in the 1950s and so on, the expectations were limited, right? So all you wanted the agent to be able to do is have very templated conversations with you. So you would say, I want to book a ticket. So it's very clear that you're not going to talk about philosophy or politics or movies or anything out of that domain, right? When you want to book a ticket, all you want to talk about is source destination, target destination, time, and any preferences in seat or mode of travel and so on. It's a very, very limited domain. So the conversations were very templated, and hence they could be implemented using expert systems, right? So since 1950s, the dominant paradigm for communication or enabling an agent to do communication was expert systems. And around this time, you would have heard of this chat bot called Eliza, right, in this era. Which was largely templated and based on rules how to respond to whatever is being asked, right? Then again around 1980s, as machine learning became more popular in the 1990s and early 2000s, machine learning was the default paradigm. In particular, probabilistic graphical models were largely used for enabling natural language processing. These were again data driven. That means if you want to build, for example, a sentiment analyzer, you show it some thousands of examples of sentences which had a positive sentiment and a negative sentiment, and then the machine can learn, given a new sentence, whether the sentiment is positive or not. Again, you can think of this that this sentence is my input X and my output Y is the label plus or minus 1, and I want to learn this function where it relates my output to the input. Again, I want to do Y is equal to f of X, and this f can be as complex as I want, and machine learning gives me that flexibility, right? So a lot of machine learning models were used to enable natural language processing. Since 2010s, or at least since 2013-14, deep learning has become the default choice for natural language processing. If you look at NLP papers published in top conferences or NLP tools developed in top companies like tech companies like Facebook, Google, Microsoft, they're all deep learning driven today, right? So today, today modern NLP is completely data driven and relies on deep learning largely and a bit of machine learning also, right? So again, this part of AI, which requires an agent to be able to communicate and hence have natural language processing capabilities, again intersects with data science, because this has now become a completely data driven field, as opposed to say 30, 40, 50 years back, where it was again largely rule based and limited to very templated conversations or templated activities with language. Okay. So now let's talk about perception. So perception is for an agent to perceive things in its environment, right? And perception clearly means the ability to be able to see, because as humans, we interact a lot with our environment by seeing or observing things. And the other thing that we use for perception is speech, right? That means we can hear things, and hence we know what others are saying or what is happening around us, and use that to act or interact with the environment, right? Now, perception using vision, that means I need to be able to give the agent the ability to have vision, and this is an area of computer vision where I focus on things like training an agent to be able to classify different objects, right? This is a horse versus a giraffe, or this is a car versus a motorbike or a cycle and so on, and that's where computer vision comes in. I also need other tasks, like I should be able to track an object, right? So I've identified a person. Now I have a video, I need to be able to track that person through the video, how he is moving from one place to another. And this is of course important in various applications like surveillance and so on, right? So anything to do with vision perception is what falls under computer vision. And similarly, anything to do with speech recognition, right? I should be able to listen to commands and be able to process them, right? Understanding of course would be on the natural language understanding part, but just to be able to recognize speech, that's where speech technology comes in, right? Again, today, modern computer vision and speech is completely data driven. It has also gone through similar cycles, like early systems were expert systems, then machine learning, and then since 2010, it's all been deep learning. Top conferences in vision and speech, most of the papers are using deep learning techniques, and even most of the deep tech companies, right, in their products, they use deep learning for this kind of perception. So again, this data driven world of AI intersects with data science. And lastly, let's talk about actuation. So actuation is in the context of physical robots, right? So a robot is an embodiment of an AI agent, and this has largely to do with robotics, right? So you learn about robots under the subject of robotics, and it also has a bit to do with reinforcement learning, because when a robot wants to navigate a space, it has to again do something similar to chess, where it has take certain moves, and the reward would come only at the end, right? Whether it reached the state or not, or whether it fell down somewhere in between, and so on, right? So again, earlier there were rule-based things for doing these or enabling actuation in a robot, but increasingly this has also become data-driven, where robots can now learn to perform complex actuations by learning from simulations or by mimicking human examples, right? So this is again a data-driven activity today. So this, of course, again intersects with AI, right? So in summary, if you want communication through natural language processing, or if you want perception in the form of computer vision or speech technologies, or a part of robotics dealing with actuation, all of this is today data driven, and this is where AI intersects with the world of data science, right? So this is how I would answer this question now. Are AI and data science related? If so, how? So this is what the question you ask in data science. I have data, what do I do with it? And this is what you do with it. You collect, store, process, describe, and build models. In AI, you ask the question, I want an intelligent agent, what do I do? You need to do problem solving, knowledge representation, reasoning, decision making, perception, communication, and actuation. And today, given that decision making, perception, communication, and actuation have become largely data driven, they now intersect this with this world of data science, right? So let's take an example of NLP. Today, if I want to do NLP, I need to collect data. Right? I need to collect large amounts of data to build sentiment analyzers, or to build translation systems, or to build summarization systems. All of these are NLP tasks. I need to be able to store it. I need to be able to process it. Processing requires cleaning of data. If there are spelling errors, what do I do? If it's written in chat lingo, how do I normalize it? All that comes in processing. I might also want to describe the data, right? So if I'm looking at sentiment data, I want to know which are the most frequent words associated with positive sentiment, and what is their frequency. Like, for example, amazing, awesome, beautiful, and so on, or horrible, boring, not watchable, or things like that, right, which might be associated with negative sentiments. I would want to get a description of the data. I might also want to know associations between words, right? How often do I see doctor and patient together, or cat and dog together, and so on. So I might want to draw certain kinds of scatter plots or co-occurrence plots between these words. So all of this is also part of doing NLP. And finally, I want to build these models. I have an input, which is the text document or the text sentence given to me. I want an output. Let's say in the simplest case, it would just be a label, positive or negative. Or it could also be a complex thing where I want to actually generate a translation or generate a summary. We'll not talk about that right now, but let's say it's just a label. I want to be able to learn functions which relate my output y to the input x. And the way to go about this is propose a machine learning model or a deep learning model and estimate that parameters of that model using large amounts of data, right? So now things have become data driven, and hence this AI part of AI, which requires an agent to be able to do decision making, perception, communication, and actuation, you need to perform data science for these activities. Same pipeline can be used for computer vision also. If I want to do image classification, I'll collect lots of images. I'll figure out a way of storing them efficiently, right? Because image data needs to be compressed appropriately. And then I will figure out a way of processing it. If there's a lot of noise in the data, if it's been taken from noisy cameras, I might want to do some filtering so that I get the details of the image. I might want to do some description in terms of typical color or brightness or other things in the image. And then finally, I want to learn models. What is the model I want to learn? I've given an input x, right, which is my input. There's a function f which relates this input to the output. What is the output? Output is one of the 10 classes, right? Whether it's a cat or a dog or a sheep or a goat or any of these things, right? Again, the same pipeline repeats in vision also. And the same example I can give you for speech also, right? So this data-driven world of AI is what intersects with data science. But there is a world of AI outside data science also, which involves problem solving, knowledge representation, and reasoning, which does not necessarily or does not intersect with data science, right? So that's why you cannot say that these are synonyms. You cannot also say that one is a subset of the other. At best, you can say that there is some intersection between the two, right? So that's what you could talk about AI and data science. And also remember, in that last corner where you have model, that's where machine learning and deep learning sit, right? Okay. So that's how AI is related to data science and how it is related to machine learning and deep learning also. Maybe at this point, let me also just talk about data mining. That's the other term which is used. So data mining is essentially performing data science on structured data. So when you have large databases and you want to do analytics on top of that to learn certain patterns, mine certain patterns, that is what data mining is called. Data mining does not deal with unstructured data. It does not deal with text, images, speech, and other such things. It's mainly about relational databases or structured databases and trying to find patterns or do modeling on top of this kind of data. Right? That's what data mining is. So that should give you a clear picture of AI, data science, machine learning, deep learning, and data mining and the relations between them. So I'll end this video here and I'll come back and answer a few more questions as listed in the learning objectives. Thank you.